So hello everyone. I'm Max Ching and I'll be your moderator for this seminar. So our speakers for today are Kay Malipol, Joel Kizon, and Nicholas Chai. So I'd like to remind our speakers that they have 12 minutes for their presentation and 3 minutes for the Q&A after. You will be reminded when there are 2 minutes left, 1 minute left, and when your time is up. So let's start with our first speaker, Kay. Kay, you may start whenever you're ready.
Can you see my screen?
Yes.
Clear.
Uh, okay. I'll start now po. So, good afternoon, VIP. So, what I'm going to present is a review article by Blanik and Schindelbeck titled Smartphone Imaging Technology and Its Applications. So, this paper consists of 17 sections, and due to the time constraint, I will only present a few sections of it. So the first part is the evolution of the mobile phone imaging system for the mass consumer market. So this is the one of its subsection, which is the conversion of mobile phone to smartphones. So a smartphone is said to be a mobile phone with advanced functionality beyond making phone calls and text messages, as it is said to be capable of displaying photos, playing videos, checking and sending emails, surfing the web. Um, it is also extended to having navigation system and augmented reality. So these functions are possible due to the mix of sensors, data processors, and connectivity. So as said, one of the functions of a smartphone is it could take pictures and videos. So with the introduction of a portable camera by integrating it to a mobile phone, it has made half of the world's population to own a camera. With that, in 2021, it was said that there are about 2 trillions of photos that will be likely taken each year, and majority of it are from smartphones. So this is due to the fact that the improvement of a phone camera offered an image quality similar to SLRs, which offers high image quality. So in most smartphones released today, there are usually multi-camera system, or there are usually 2 to 4 rear cameras, even the mid and low end smartphones. So this is an example of a phone with a triple camera system. This is a Sony Xperia, and it includes an ultra wide angle lens, a telecamera, and uh, this is a standard wide angle, or more referred to as the main camera. So these are some important vocabulary words. The field of view is the angle which the device can pick up electromagnetic radiation. The minimum optical distance, or the shortest working distance between the foremost lens and the object. And the depth of field, or the distance between the closest and the furthest object within a composition. So in a normal quadruple multi-camera system, which has 4 rear lenses and a front camera, these angled lines presents the field of view of each camera, and then these numbers presents the MOD, and the dashed lines are the DOF at each MOD. There is also this object field diameter of the front camera and the rear cameras. So as one of its applications, smartphone camera was tested by placing it on a telescope, a microscope, or by attaching different clip lenses. So this is an image of the moon captured by placing the smartphone camera on the eyepiece of a telescope directly and without the need of any additional optics. So this is possible because the entrance pupil of the smartphone is similar to the entrance pupil of a human eye. So in using a 28 millimeter equivalent wide angle lens, the entrance pupil is around 2 to 4 millimeters, which is similar to the day vision of the human eye. Since the exit pupil of a smartphone camera is also at its the rear part of the device, it can be placed on the position of the optical instrument's exit pupil. The captured image field angle of a typical high quality eyepiece is often around 60 to 70 degrees. So it is completely captured by the wide angle camera of a smartphone with an FOV of around 70 to 80 degrees. So this is an example of a smartphone attached on a spotting scope. Uh, since centering the phone to the pupil to take freehand photos is a matter of patience and luck, there have been available adapters to properly attach the smartphone uh, to a spotting scope. However, these are only suitable for a limited number of eyepieces and for some certain smartphones. In the market, these are some of the available accessory lenses, which can cause changes in its focal length. Some of these lenses include the macro lens, a wide angle lens, and the telephoto lens. Um, with these lenses, however, significant effort is still required to have a high contrast and distortion-free images. It must be noted also, however, that most of these lenses were already integrated on existing smartphones, such as the wide angle and the telephoto. However, macro lens integration is still rare. One of the examples of the smartphones with macro lens is Nokia 8.3. It has a quadruple camera system, and this is the example of a macro image using its macro camera. This achieves a magnification of around 1 is to 6 to 1 is to 8. Therefore, in this review where I got this picture, um, they have said that the macro camera here for the phone is a letdown. Also, it also poses some problems that is requires a close distance between the phone and the object, and it must cover a lot of ambient light. This is why attaching a macro lens for macro photography is still better than this integrated macro lens. As for the microscope attachments, like in the spotting scope and telescope, one can also attach a microscope lens to the smartphone directly. In figure 11 here, it shows an image of a smartphone camera, a microscope lens, and an image sensor, its specimen, and its light source. This is possible to be this imitates a normal microscope setup. And this is possible because the diaphragm is in front of the first lens. This achieves 1 is to 1 image magnification, but it has a limited resolution by the pixel sensor size due to the high optical quality. Since pixels are about 1 micrometers in size, the object detail resolution is about 2 micrometers, which is still comparable to that of a professional microscope. But unlike in the case of a macro lens, smartphone microscopy is not an add-on anymore because this phone, which is Oppo Find X3 Pro, they have already integrated a microscope lens and has achieved magnification of 1:1. These images are the sample microscopic images captured using this phone. This is from this Engadget article. So to summarize, smartphones have almost completely replaced compact cameras. However, this still has its physical disadvantages as it is limited to achieve very high pixel resolution. It has a very large depth of field. This small pixel size results in low light per pixel, which increase noise or longer exposure time. And due to the space limitations of a smartphone, optical zoom systems are often not possible. However, these limitations lead to a
To
more
itself.
dynamic technology development. With the continuous improvement of technology, other types of lenses could be possible to be integrated to smartphones. So that's all for my presentation. Thank you.
Thank you, Miss Kay. We still have a lot of time for questions. May we call on Ma'am Jing for the first one?
Yes. Can you hear me?
Ah, yes, ma'am.
I thank you. Nice choice of paper. Could you show again the table of contents?
Ah, yes. Wait, ma'am. Here po.
Okay. So, oh, all right. So the paper only focused on the optics. Because the smartphone, what's interesting about the smartphones right now are the variations of sensors that are included, like uh, GPS, uh, uh, gyroscope, range, etc. So
Yes po, ma'am.
not, none of that was mentioned in the paper, no? It
Um,
seems.
those sensors are only mentioned in the first part where they said that here lang po. Pero ma'am, the paper focuses on the optics part po of the smartphone.
Okay, thanks.
Thank you, ma'am. Let's move on to the next question po. Kuya Jem?
Okay. Since
Po.
this is a review paper, were you able to recommend what's the best smartphone for macro imaging?
For macro imaging, I think it still depends on the smartphone po kasi and the macro lens that you will use. So,
Pero,
pero based on some reviews po, I think what they recommend is I think iPhone iPhone
iPhone, I see.
I think they have a review about iPhone 7 Plus because I think they have mentioned, if I can remember it correctly, they have mentioned that that is one of the pioneers of having two rear cameras po.
What year was this again published?
Ay what sorry
What
hindi ko
year
masyadong
was this published?
2021 po.
2021. I see. Okay, medyo recent lang. Thank you.
Thank you, Kuya Jem. Do we have any other questions? No na? Thank you again, Miss Kay. Let's proceed to our next speaker. Jewel, are you ready?
Hello, yes, I'm ready. Wait lang po.
Okay.
Ah, kita na po ba?
Yes. Jewel, you may start whenever you're ready.
Okay. Hindi siya nag-respond. Wait lang po. And, okay. So good afternoon, everyone. The article I am about to present is Edge Detection based on Computational Ghost Imaging or CGI by Sheng Xuan, Dongshang, Shumei Liu, Xinju, and Pi Binbing on Optics Communications, Volume 410 on March 1st of March 2018. So here are the contents of the presentation. And for the introduction, the edge of an object can be extracted by a series of structured illuminations generated by the edge modes of several spectral intensity patterns. This paper proposes that two current light beams interfere with each other after being modulated by two phase-only spatial light modulators or SLMs, where a series of structured intensity patterns are generated at the object plane. After, finally, the light transmitted from the object is converged into a single pixel detector. Okay, so here po. Ay, mamaya na po. Opo. Opo, okay. So, sorry. Here on on the schematic diagram, a collimated laser beam illuminates the SLM, which is controlled by a computer to generate a series of random phase patterns phi. The modulated wavefront then is diffracted at distance L to the object plane. This can be computed by the Fresnel-Huygens propagator. For each phase realization, the bucket detector measures the total transmitted light after the intensity pattern I interacts with the object T, as shown in this in this equation where data B is measured by the bucket detector T. The paper then assumes a horizontal and vertical gradient patterns of I, which are extracted by the Prewitt operator, which is an edge detection operation, dividing them into dividing the then equation T into a pair of measurement data, where the horizontal and vertical edge of the object is imaged by the correlation operation after m number of measurements. Okay. And the structured intensity patterns are generally grayscale, but the digital micromirror device or DMD is a binary device. For this to work, several binary patterns must be generated by DMD to form a grayscale one. However, this can produce errors as errors can be generated in quantization of grayscale patterns, in the distance from the object, and the diffraction of light. So this diagram, this can be solved and explained in the paper as shown in figure 2, where the interference of two coherent light beams where phase-only masks in the two arms generated by the SLMs are obtained according to the interference principle. So, um, so the laser is then splitted by the beam splitter 1 and then reflected to the SLMs, wherein uh, phases are generated and then they are combined in the beam splitter 2 and then projected into the object. Okay. So here, the phase-only masks phi1 and 2 can be obtained by the following equations here, where the argument and the absolute represents the angle and the modulus extraction of the argument, respectively. This process is completed to obtain said phase-only masks. As shown again here in figure 2, the SLMs in the two arms are controlled by the computer to generate acquired phase masks, which interfere and produce the intensity pattern on the object plane. Simulating the results, wherein a numerical simulation with a 128 by 128 pixels is taken as the original image to verify the proposed method. So the wavelength of the light is 632.8 nanometers, and the diffraction distance is 50 centimeters, wherein 10,000 horizontal and vertical patterns are generated. So, A is the original image, and then B is the retrieved image based on CGI. Okay, so from here, both of these are both of the edges of A and B are obtained by normal means through C and D, wherein it can be observed here that that the edges are not uh, clearly obtained from B, and then the proposed method E, wait. The proposed method E and two other methods wherein the first one is the edge detection based on gradient ghost imaging, and then the second one is the edge detection from speckle shifting ghost imaging using Sobel operator as obtained here in E to G. So as observed here, the proposed method and the SSGI using Sobel operator show similar results. Comparing these two, a signal to noise ratio is used to evaluate the quality of edge detection. Testing these trends with varying number of measurements. As seen here in figure 4, the signal to noise ratio of edge detection results gradually increase. But the proposed method produces a higher signal to noise ratio than that of the SSGI using Sobel operator proposed by Mao under the same conditions. So going back here, both F and G are the SSGI method, but the only difference is G, image G is enacted upon by Sobel operator. We're in the paper proposed by Mao discovered that while other edge detection operators uh, were eh, were also used, they discovered that using Sobel operator has the best property in utilizing edge detection methods. Okay. So according to slide 4 with the Pruitt operation, horizontal and vertical patterns are computed as shown here in A and B. So here, these patterns are computed from the intensity I sub r of a random phase mask in its Fresnel diffraction domain. Okay. And then corresponding phase masks phi1 and 2 are computed as shown here from C to F respectively. And evaluating the similarity between the original intensity pattern and the reconstructed one, the correlation coefficient is defined by this following equation. So this is the equation for the uh, for the correlation coefficient, wherein the figure shown in the previous slide both have a correlation coefficient of 0.999. Ayan. And lastly, for the results, in this edge detection system, the distance deviation is also unavoidable, as the distance L in the computation is not seen to be exact to the point as it is in the actual system. So this paper this paper aims to ascertain the effects of distance deviation and its signal to noise ratio. Okay. So we can observe here in figure 6 that the system has a certain tolerance to the distance deviation. As for deviations reaching 5 millimeters, the boundaries are still sharp and visible from here in this one. While in increasing distance deviation results in the edge indistinguishable as shown here. Okay. In addition to this, um, in addition to the interference with SLMs, DMD can also be employed to generate the structured intensity patterns in ghost imaging. However, this requires DMD to display several binary patterns to form a grayscale one, resulting in the quantization error of grayscale patterns to occur. This paper also tackles that, where as shown here in figure 7, the extracted edge is blurred when the grayscale intensity patterns are quantified less than 32 levels. So from here, any less than 32 levels or 5-bit, the extracted edge is blurred. While in increasing levels, the extracted edges are more visible and prominent. Finally, this method also proposed in the paper that the method is suitable for grayscale objects as shown here in figure 8, wherein the subject, in this case a bacteria, is subjected to 50,000 measurements to extract the edge as shown in B, which has a signal to noise ratio of 8.72. In conclusion, This paper proposes a new edge detection method uh, based on a series of structured illuminations generated by the interference between two coherent beams, wherein the edge can only be extracted from horizontal and vertical patterns, and this works for both grayscale and binary objects. This paper also found out that this is clearer than the SSGI using Sobel operator proposed by previous paper under the same conditions. So that's all for my presentation.
Thank you, Joa. That was actually 2 minutes left. So we still have a lot of time for the questions. Do we have questions? Yes, Ma'am Ritz.
Sorry, okay. Great presentation, Joel. So for my first question, is the edge detection process integrated in the acquisition part of the imaging, or is it a post-processing thing? Hello?
Hello, I can hear you. Paulit po. No? Can you repeat the question? Sorry.
Um, is the edge detection process integrated in the acquisition part of the imaging, like sa experiment ba siya, or is it a post-processing thing?
Based on my understanding, the edge detection process is integrated into the process. Yeah.
Mm-hmm. So they did that using the vertical horizontal pattern like integrate thing, right? So how did they produce the vertical and horizontal patterns? Like for the vertical pattern, do you just rotate the horizontal one and vice versa?
Oh, for creating the vertical and horizontal patterns, it is computer generated by the um, SLM or the spatial light modulator, and then wait. Okay, so
Can
it is.
you
I
show the
sorry.
patterns again? Sorry, in your slides.
Oh, okay. Wait. Share screen. So this is the slide. Yes, this one.
Sorry, with the patterns.
Oh, this one.
Yeah.
Oh, okay. So um, these horizontal and vertical patterns are computed from the intensity of a random phase mask in its Fresnel diffraction. Yeah. So I think I think it's random. I think the phases produced are random, and I didn't see um any mention of it being just the same phase only rotated 90 degrees. Yeah. So
Hmm.
I didn't see that in the paper. It
I was
only
just curious,
yeah.
why do they call it horizontal and vertical gradient patterns?
uh I think they called it horizontal and vertical patterns due to its uh orientation, I guess. It due to its orientation as it appears on based on its orientation as it appears as shown here in figure 5. Yeah.
Mhm. Or are these two patterns from the SLMs? Do you have two SLMs, right? SLM1 and SLM2.
Yes.
And then they let the patterns produced by the SLMs interfere with one another to produce the actual pattern that's going to be multiplied or multiplied to the object, to the ground truth.
Yes. Yes.
Hmm, okay. All right. Thanks, Jewel.
Pwede na ako?
Sure, ma'am.
Ayan. Hello.
Hello.
Why again was okay? I understand the SLM just blocks light, so it's just 1 or 0. But why again do they need grayscale levels?
Um, wait. Because the structured, I didn't need the grayscale. Wait, can you repeat po the question again? Sorry.
Okay. Why is there a need to generate grayscale patterns? This is structured light illumination, right? Okay, so
Yes.
and the pattern that they are projecting on the image is a random pattern, albeit these patterns when they interfere produce either horizontal or vertical random patterns as well. But why do they need to have you mentioned grayscale? Why do they um do they need how do they generate the grayscale and why do they need it?
Um, the structured and uh intensity patterns are generally grayscale, but why do they need it?
Anyway, just think about it and you can answer afterwards
Okay po.
by email.
Okay po. Thank you.
Okay, so we have no more time for questions at this point. Let's move on to our last speaker, Nicholas Chai.
Hello, am I
Hello.
audible?
Yes.
Thank you. Hello, is it visible?
Yes, you may start whenever you're ready.
All right. Good day, everyone. My name is Nicholas Chai. I'll be presenting a paper entitled Local Amplification of Tsunami Waves along the west coast of Negros Island and Panay Island by these Chinese authors. This is to be published in June 2022. So, hindi pa siya napapublish in the Applied Ocean Research Journal. Here's the link to the paper. It's available online. This is a very interesting find because this is situated in the Philippines, but the researchers are Chinese. For an overview, Panay Island and Negros Island is in the east of Sulu Sea and faces a hazard of near-field earthquake-generated tsunamis. This study aims to assess the tsunami hazard along the west coast of the two islands caused by these near-field earthquakes with largest possible magnitude and focuses on the high hazard spots, which are always attacked by higher tsunami waves. A series of tsunami scenarios in the area are numerically simulated using FVCOM, a finite volume community ocean model. The largest historical tsunami in the recent century is then simulated and reproduced, and the results were in good agreement with the historical observation. Now let's start with the very simple background of a tsunami. So tsunami can be caused by undersea earthquakes from faults that generate upward water displacements, and then they form waves. As these waves approach the shoreline, like the height of the water decreases and the wave needs to increase as a result. So these tsunami waves are very dangerous to coastlines. Okay, so next we are studying the Panay Negros area. Here's the bathymetry of it. So here is Panay Island and Negros Island. And then here is the Sulu Sea, where we have Negros Trench, horizontal, and Sulu Trench, diagonal to it. So the water depth of this is around 5,000 meters or 5 kilometers. And this is very It's a very steep trench here. So it's very dark blue and then increases in depth uh, as it goes to Palawan microcontinental block. Here shows the dots show the historical earthquake data, where the green ones are from 5 to 6 magnitude in the Richter scale, and then the purple is 6 to 7, and then there's 1 7 to 8, which is this red dot, which is the largest magnitude historical earthquake from 1907 to 2016. We will elaborate on this later, this red dot. So here, let's just focus on the region in the Panay Island and the Negros Island. And then here is your Negros Trench. We will consider 4 epicenters along the trench, NT1, NT2, which is the site of the earthquake, NT3, and NT4. We will look at a few regions. So this is region 1, region 2, region 3, region 4. And then for the coast, we will analyze the west coast of these 2 islands, numbered from 1 to 91 in 5-kilometer intervals. We will elaborate on that later. But the earthquake in the region, the largest recorded tsunami, is caused by the 1948 Lady Kaikai earthquake. From the NGC, National Geophysical Data Center, a surface wave with a magnitude of 8.2 hit the Panay Island here. So here's the earthquake, and it hit the Panay Island, causing a tsunami with 2 casualties along the Iloilo Strait, January 25, 1948. Accounts say that there was a 2-meter tsunami that hit the Iloilo Strait. Here's the example of the damage during that time. So this is from 1948. The model they use to simulate this is the FVCOM. It's a unstructured grid finite volume community ocean model. This uses a finite volume method to simulate fluids using an unstructured grid. This is suitable to study the flow in estuaries and coast with complex and irregular geometry. Just like here, we have very, very specific detailed geometry that we need to simulate. But this needs data about the initial water disturbance to simulate propagation. To obtain these, we use the Okada surface deformation model, which takes in seismic parameters like your magnitude, your focal depth, your strike angle, and the dip angle. So we can determine how much water disturbance there is to form a tsunami. So just a review, here is an example of a fault, and then here is your strike angle, the angle relative to the north, if you're looking at the map. So the angle is the strike angle, and then the dip angle is the angle relative to the seabed, so downwards angle. Okay, so here's the unstructured grid consisting of volumes, tiny triangle volumes that is used to simulate the tsunami. I will not elaborate on that further because it's very complex. So they simulated this largest historical tsunami, the tsunami from the Kaikai earthquake. But here they use the data from the US Geological Survey, which is said to have a 7.8 magnitude on the Richter scale, a fault depth of 15 kilometers with the same reported maximum run-up height of 2 meters along the Iloilo Strait. Again, here it is, the area. And then here is the graph of the coast section, numbers 45 to 60. So 45 along the coast, 60. And here we see that the area close to 45, which is Iloilo Strait, had the 2-meter run-up height or the tsunami height. So this simulation is very consistent with the accounts from the historical events. Moreover, the water level was about 0.9 according to the accounts, and which satisfy here with the simulation. Now, they also analyzed, now they essentially prove that the model can simulate actual tsunami. They wanted to analyze what is the maximum credible tsunami that can form from this kind of high magnitude earthquake. So they want to analyze the effects of the epicenter location, the strike angle, and the dip angle of the earthquake for the tsunami formation. So again, they analyze NT1, the region NT1 as an epicenter, NT2, NT3, NT4. All of these are magnitude 7.8 earthquakes with epicenter depth of 15 kilometers below sea surface. Okay, so here is an example of your NT1 wave tsunami, right, with a strike angle of 0 and a dip angle of 10 degrees. Here is NT2, lower than this. This is along the Negros Trench, just a remind. And then this will have a different angle, 340 degrees, and so on, NT3, NT4. These are the specific details. And then here is the result of it. Again, here is the cross section, coast section, I mean, with the highest wave heights. Let's analyze this one by one. Let's start with this region from 1 to 44. So here it is, Negros Island. Let's start with here. We see the black spikes corresponding to NT4, the region NT4 here, the epicenter here, would cause very high tsunamis from 2 to 10 meters high in this region. And as we move along, we see that the peaks now start to be from the NT3, which is closer here. And then in the Panay Island, here, caused by the NT3. And then in this section, which is here, it's now dominated by NT2, which is blue. And then here, it's dominated by NT1, which is red. So as expected, the influence of the epicenter location in near field earthquakes is huge in the coasts, right? We can see spikes depending on how close you are from the epicenter, as expected.
2 minutes left.
Okay, next, we noticed that some coast sections, namely 1 to 13, 16 to 30, experiences high spikes of wave heights. So this can be seen along the west coast of the Panay Island and in the Negros. So in these spots, we can see that there are spikes, irregular spikes. These are manifestations of the local shore geometries to be explained here. So where does these high-risk spikes come from? Well, one of these are from the region 1, which are said to be caused by edge waves. Edge waves form along the coast. So if you have a source here and then traveling wave, it travels, and then it hits a coast, not but at an angle, the tsunami would proceed along the coast, along the edge. It will form an edge wave. And this edge wave is said to be one of
One
the
minute left.
high hazard areas that could be produced. Next is superposition of incident and reflected waves. Essentially, when you have waves traveling in a perpendicular coastline, these reflected waves can essentially add up here and here, causing also high hazard area. Another one is a bell-shaped mouth, basically a narrowing of the channel, also causing high hazard area. And lastly, refraction around the cape. Essentially, this point at the very tip experiences the very high hazard area. So conclusion is that they were successful in performing the numerical simulation of tsunamis in the Panay and Negros Island. And then these are very sensitive to seismic source parameters like epicenter. And then there are always some high hazard areas that are due to topographic features like a concave gulf, bell-shaped mouth, a cape, or the formation of edge waves. These local amplification effects should be considered more during disaster prevention. That is all. Thank you for listening.
Thank you. Do we have questions? Yes, Ma'am Jing.
Did you take a look at the model that they use? Because for this, you would need, I believe you would need bathymetry information besides coastline information, yeah?
Yes,
So
you need bathymetry information.
bathymetry. So essentially, it's like a 3D. Is
Yes,
that right?
po.
Because you need depth
Yes.
and area. No?
Yes, po.
And then I suppose it's a computational fluid dynamics tool.
Yes, po, ma'am. It is used
Yeah.
to model ocean waves, so it can also model these. Yeah, essentially, this is a very complex model, unlike the previous Boltzmann methods. So it uses a lot of data from bathymetry, the coastlines, and then probably computationally intensive too.
Absolutely. Okay.
Yeah.
And then this model is freely available to be used.
Yes, it is open
Okay.
for everyone.
Thank you.
All right. Thank you, po.
Do we still have any more questions? I guess that's it for our questions. This for the speaker. Ma'am Jing, Ma'am Ritz, do we have any announcements po?
I think we still have one more week available for seminar, right? Rain, do we have a schedule for the next, who the
Yes
next
po.
speakers are?
Next meeting would be our last, and our speakers then would be Aldrin Urbi, Mar Miranda, and Abdel Sinapil. I'm just not sure if Abdel would make it. Ma'am Ritz, do we have news po?
Hi, Rain. Walang news from Abdel. So yeah, last contact with him was February ata. Yeah.
Okay.
Okay. So
Sige,
I think
thanks.
we only have 2 speakers for next week, and it will be moderated po by Ja Ardonia.
Great. Okay. I think that's it. Watch out for case and Max's thesis defense. I think they're on the same day, tama ba? One is in the morning, one is in the afternoon. Please show your support to your fellow VIPs by attending their thesis if you can. Kung wala naman kayong exam, okay? Ano nga ba yung schedule mo, Max? Ano yung schedule mo, Kay? Okay,
Hello?
what's your schedule ba? Yeah?
Ako po ma'am ay May 31, 4 p.m. po.
Okay. And Max, I think you're
Hi.
in the morning, tama ba?
Hello po.
What
Yes,
time is
ma'am.
now?
9:45 po, same day.
Okay. Announcement will be given. Anong day ito? Anong day ito?
Tuesday po ma'am.
Ha?
Tuesday po.
Tuesday. Sige. All right.
Ah,
So
Ma'am
our
Ma'am Jane, I have a
Yeah?
question po. Yes, ma'am. May mock defense po ba sila?
pwede. Just pwede naman.
Mhm.
So kanya-kanya na lang na na announcement, okay?
Okay.
Katulad ni Kay, kailan ba tayo kay magma-mock defense?
Ma'am, baka po
Diyan.
next week. Okay
Yeah,
lang
Ja,
po.
you're raising your hand.
Yes po, ma'am. Remind ko lang po yung mga hindi pa nakaboto sa USC elections. Mag-e-end po mamayang 6 p.m.
Yan pa, may announcement pa. Up to 6 p.m. Okay. So sometime next week, free time namin ni Kay, those who can attend the mock defense and give feedback about their presentation. Okay? Okay. Kung wala na, may announcement pa ba? Wala na. Kung ganun, ay magpakita na tayo and kuha tayo ng picture. Gusto ko lang yung background ko kasi kita yung mga linabhan ko. Okay, yan. Hi guys. Kapit lang guys. I know. Kaya yan. Lapit na ang SEM and focus muna. Focus muna sa ACADS, ha? Kaya natin yan. Command, Shift, I. Tama ba? Capture. Capture entire screen. Capture, ready? Ngiti. Kahit luhaan. Ganun eh. Labern lang. Sige guys. Okay. Thank you. Ingat
Thank you
parati.
po.
And see you next week.
Bye.
Bye.
Bye.